Hey mathletes, so today's lesson is going to be on function values. So previously we talked about a function being a relation where every input relates to only one output. So if I put one thing into this function machine, say 3, I'm going to have a rule that applied to it. I'll get one thing out of it, in this case 8. So the input is the independent variable, or the domain, and the output is the dependent variable, or the range. So I plug in 3, so f of 3, to find out what that is, we do 3, parentheses 3, minus 1. Then we want to use our order operations. So we have multiplication and subtraction, so we multiply first. So 9 minus 1, so f of 3 is 8. Make sure after you substitute the value they give you in for x, that you then use order of operations. So we know that if x is 3, the output is 8. What if x is 5? So we read this as f of x. So f of x is just another word for y. You could have this written as y equals 3x minus 1. We're talking about a function. So it's named f. Could be named g, h, b, d. The reason you name a function with a lowercase italics letter is so you can tell them apart. So this is function f. F of x also just means y. So what they're asking here is what's y if x is 5? So where you see x in the function, you're just going to put a 5. Make sure you put it in parentheses just in case it's negative, and then use order of operations. So 3 times 5 is 15. So then 15 minus 1 is 14. So f of 5 equals 14. What if x was 0? F of 0. So again, this just means the y number when x is 0. So substitute it the same way, 3 times 0 minus 1. So multiply first, 3 times 0. Again, the 0 property says anything times 0 is 0. So 0 minus 1, so f of 0 is negative 1. So that's finding a function value if you're substituting a value in for x. That's easy. But what if the output value is 26? So what if f of x equals 26? Well, that means you're going to put that here. That's f of x. So f of x is 26. So now it's 26 equals 3 times x minus 1. So now you're solving for a variable. So we're reversing the order of operations, remember. So 3 multiplied by x, subtract 1. So we reverse it. Instead of subtract 1, you want to add 1 to both sides. Leaves us with 27 equals 3 times x. Again, the opposite of multiplication is division. So divide both sides by 3. And 27 divided by 3 is 9. So x equals 9 when f of x is 26. So sometimes we don't know what the function is, what the equation is. So this is some exponential graph. I don't know actually what the equation is. We could figure it out if we had to, but we don't need to. This function's name is g. This is g of x. So using a graph, how do we find g of 2? Well, it's supposed to say g of x, so if it says g of 2, that means 2 is the x value. So 2 is the x number, follow that to the graph. That's what the graph is. So now follow that over to the y number. And that's what the y value is of the graph when x is 2. So obviously that is 5. So g of 2 is 5. What about negative 2? Well, g of negative 2 just means what's the value of g when x is negative 2. So if this is the origin 0, 0, this is negative 2. So follow that to the function, and then follow that straight over to the y-axis. And here it is halfway between negative 2 and negative 3. So since it's a graph, and it's not exact, we can only say it's about halfway between negative 2 and negative 3. We're going to call that approximately negative 2.5. So just like the last slide, when we tried to figure out what the x value is from a y number, we can do that here as well. If we know that, remember, g of x is just another way of saying y. So they're saying y equals negative 1. Well, negative 1 is right here. It's on the graph, and the x number there has to be 0. So we look for where y is negative 1. This is where y is negative 1. It intersects the graph right here, and so you go up to the x-axis, and that's at 0. So when y is negative 1, x equals 0. Again, all we're doing is looking for the x value, going to the function graph, and then finding the y value, or vice versa. We start with the y value, look for where it hits the graph, and follow that to the x value.